Hi guys, happy Wednesday. Good news, we are almost at the halfway point for the week. Once we hit about 12 o'clock, we are halfway through another week of all this online learning. And so I'm really proud of you guys for just stepping it up while you've been at home and taking on this learning and just kind of going with it and doing your best. It really makes us happy. Today we're doing a continuation of yesterday, learning how to draw tape diagrams for different types of problems, right? So we all remember that there are 4 operations in math: addition, subtraction, multiplication, and division, right? And so each problem requires us to draw out our solution in a different way. So that being said, let's go ahead and move on to multiplication and division for today. Alright, so here's my anchor chart. It's the same anchor chart as yesterday, right? Tape diagrams, except today we're moving on to multiplication and division. The reason why multiplication and division is separated, I went ahead and separated it from addition and subtraction, is there's a little bit more that goes into making these ones. We didn't get to spend a whole lot of time on working word problems in our Eureka textbooks when it came to multiplication and division problems, just because of the pacing of everything. So this is almost kind of a good thing that we're getting a chance to go ahead and go back so that we can go over this again. So when we are doing a multiplication problem, it is a lot like an addition problem, where what we know is going to go ahead and be what's at the bottom of our tape diagram, and we are solving for a total. Now, where it gets different is it's not just a couple parts we're putting together. Whenever we're solving a multiplication or a division problem, when we are making the bottom part of our tape diagram, we are talking about groups, and we are talking about numbers in a group. Okay, so to help explain groups and numbers in each group for those of us who are still struggling, I have these dried cranberries. I really wish I had candy in the house, but I don't, because it would be so much easier if I had something like M&Ms. So we're using dried cranberries. So I have 1, 2, 3, 4, 5, 6, 7, 8. So we would call this one group of dried cranberries. So that is one group, and in that group I have 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, how many groups would I say I have now? 2, right? I have 2 groups, and the number in each group would be a group of 4, a group of 4. Okay? Let's see. Now how many groups do I have? I have 1, 2, 3 groups and 2 in each group. So if I were to come here, I would have 1, 2, 3 groups, and there would be 2 in each group. So hopefully that makes a little more sense when we go through this. So when we are solving for our multiplication problems, what we need to be able to pull out of the problem is the number of groups they're talking about and the number in each group. And remember, if it's a multiplication problem, we are solving for the total. Now that could look a little different if it's a multi-step problem in which you have to do some multiplication, some division, maybe some adding or subtracting. But if it's strictly multiplication, number of groups, number in each group, we're solving for the total. Now, division will look a little different. Just like with subtraction problems, we know a total and we know one of our parts, and we're solving for a missing part. In a division problem, we're going to know our total, and we're either going to know the number of groups or we're going to know the number in each group. So if I said I had a total of 8 cranberries here, we're going back to the cranberries. I really need to get some M&Ms. So if I said I had a total of 8 cranberries and I showed that there are 2 cranberries in each group, how many groups would I have in total? Right? So it'd be 8 divided by 2. I would have a total of 2 groups, right? 2, 2, 2, 2. So in that situation, I knew my total and I knew the number in each group. All right, so what if it's different? What if I know my total? I have a total of 6 cranberries. And I know that there are 3 groups, right? So now we're solving for the number in each group. So it would be 6 divided by 3. There are 2 in each group. So hopefully this is helping us understand it just a little bit better. Okay, now that those cranberries are gone, let's move on into some problems. Remember these problems right here off of this worksheet, I printed off outside of an outside source. So it is not part of your packet. Remember, yesterday and today we are only practicing. So really all you're doing is you're reading along with me on the problem, and on a blank sheet of paper, you're just working the steps with me. Tomorrow we will be back in the packet doing word problem strategies, this page right here, okay, but that'll be tomorrow. Remember, these questions right here, they are not in your packet, okay, so don't worry about trying to find them. They're not in there. So this question right here, Arnold sent out 25 packages of nuts. There are 25 peanuts in each package. Some of the packages, P, remember we use letters as variables when we don't have a number for it, also have 10 cashews in them. In all, the packages have 735 nuts. Which equation represents this situation? All right, just by reading this, I can already tell that this is going to be a multi-step problem. All right, so let's just figure out what we know here. All right, we know that there are a total of 25 packages, right? And we know definitely there's 25 peanuts in each package. So right here, I'm already kind of starting to build in my mind what my tape diagram is going to look like, right? So I know number of groups and I know number in each group. This is where it kind of throws us, right? So some of the packages have 10 cashews in them. I don't know how many packages, right? That's still kind of up there. And then finally it gives me a total. In all, packages have 735 nuts. All right, I know this says which equation best represents, but what we're going to be solving here is how many packages have cashews. So now we need to move on to our tape diagram. Now, usually in the tape diagram, if there's going to be a lot of groups, we don't usually do them, but for this one we're going to go ahead and just do them. All right, so here are my 25 packages of nuts. I know in total I have 735 nuts. Now remember, we're dealing with 2 types of nuts here. We're dealing with peanuts and cashews. So over here I might write something to myself, peanuts plus cashews equals 735. Now, there are 25 peanuts in each package. So the number in each group is going to be 25. So So you can go ahead, you can write 25 in every single one, or just in a few, and just show that it continues. So we know that only a few of them have 10 cashews. We don't know how many. So maybe over here, I'll write something over here. There are 10 cashews in some of these bags over here. We just don't know how many yet. So looking at this, what is the first thing I should try to figure out? With the information I have, what type of problem or number sentence can I come up with? Well, if I look here, I know I can definitely figure out how many peanuts I have, right? There are 25 packages in total, and in each package I have 25 peanuts. So the very first thing I can figure out is how many peanuts I have. Okay, so it looks like I have 625 peanuts. Okay, so now that I've figured out peanuts, can I figure out how many cashews there are? For this, we could actually even do another tape diagram, right? In this case, I know how many nuts I have total. I know total. And I know one of my parts. What kind of operation is this tape diagram right here? What kind of operation are we doing? This is a subtraction problem, right? I know my total, I know one part, I'm solving for an unknown part. So if I take 735, subtract 625, I'm left with 110. That is how many cashews. So, looking over here, we still haven't solved our main problem, right? All I know is I have a total of 110 cashews total, and 10 of them are going into each bag. So, figure out how many bags of cashews. I have a total of 110 cashews. 10 cashews go in each bag. So, knowing this, does this tell me the number of groups I have or the number in each group? This would be the number in each group, right? So when I set up a tape diagram like that, I show a couple groups because I don't know how many I'll have total, and in each one, I have 110. Sorry, I have 10. 10 cashews. So this is a division problem that we set up here, right? I know the total number and I know the number in each group. I'm solving for number of groups. So 110 divided by 10 is bring down the 0. 10 goes into 10 one time. Multiply it back out. 11. So in here, we figured out that there are 25 total packages. There are 25 peanuts in each package. How many of these packages have 10 cashews in them? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we have our new problem. Tommy bought P boxes of 23 paper clips. He already had 38 paper clips. Now he has 107 paper clips. How many boxes of paper clips did Tommy buy in all? All right, so first thing we do, we read it. Now let's pull out what information we know and what we don't know. Okay? He bought P boxes of 23 paper clips. So the first thing I realize here is they're using P instead of a number. Remember, we call this a variable. This is one of my unknowns. I do not know how many boxes. We do know, however, that in each box there are 23 paper clips. All right, so now they're adding a little bit more information in on this, right? He already had 38. So this is something he already had. Now he has 107. So from looking at this, from what I know number in each group, an additional number, and a total. Okay, so let's just not think about this right here for a minute. We're going to set that off to the side. We know number in each group. We know total. What type of tape diagram am I setting up here? It looks like it's going to be another division problem, right? I know number in each group. I don't know number of groups, but I do know a total. So we can go ahead and set that up. Okay, if I don't know the number of groups, we just draw a few, add in some ellipsis, because we do not know a total, but we do know there are 23 in each group. Now, this is where it gets a little tricky, right? Because he has a total of 107. But we cannot forget about the 38 paper clips he already had. That is in our total. So over here, we need to show the 38 paper clips he already had. Now, by doing that, what does our tape diagram look like here? It's not necessarily a strict division problem anymore, is it? Where I know number in each group. Because now I have this whole different set of groups, right? With a different number in it. This is looking more like a subtraction problem. I have a part, I have a total, and I have an unknown part. My known part, my unknown part, my total. So this tells me to solve this problem, the first thing I need to do is subtract. So if I take 107, subtract 38, remember when we subtract, the first thing we do is to go ahead and try to borrow across, right? I can't take away 8 from 7, move over, can't take anything there, move over. There we go. 17 minus 8, 9, 9 minus 3, 6. Okay, so what we figured out right now is of those boxes of paper clips, there's a total of 69 of those. So what we did to get to this part, we took away 38 of the paper clips he already had. From the total number of paper clips that he ended up with, we found out that from those boxes, there are 69 paper clips in them. Now, with this looks a little bit more like a division problem, right? We know our total, we know how many are in each group, we just don't know total groups. So, now I can go ahead and solve using division. All right, so we haven't really done this yet where we've done a 2-digit divided by a 2-digit. We won't get into that till 5th grade, but just watch as I do this, right? So It's a little difficult, so what we're going to do is we're just going to actually cover up the ones place in both of them. And we're going to see how many times can 2 go into 6. 3 times, right? 2 times 3 is 6. So when we take that 3, we're actually putting it on top of the tens place because we're going across both numbers. So 3 times 3 is 9. 3 times 2 is 6. No remainders. So we figured out that there are 3 boxes of 23 paper clips. Okay? And if we're going to go through and check our work, there are my 3 boxes. There are 23 paper clips in each box, and the 38 paper clips Tommy already had. If we add them all together, we should end up with our total of 107 paper clips. Again, problems like this are going to take a lot of practice because there are a lot of steps involved. So the best thing we can do right now is get really familiar with how to draw out in a tape diagram what the problem is asking us. So what I want you guys to be able to practice is figuring out our knowns and our unknown parts and how to go ahead and build a tape diagram off of that. And then if it's a multi-step problem with a bunch of different operations, can you see where we went from just a straight division problem to now we're turning it into a subtraction problem? One group, and a whole. So just like yesterday, I'm only going to leave you with one problem since these are just a little bit more difficult. All right, so this is your problem you are doing on your own. Okay, so this would be a good point in time in the video. Just read it through, pause it so that you can still have that information there. What I would actually recommend is if you actually wrote down the problem, that way you can do what we are doing in previous problems with pulling out, underlining, and pulling out the information we need. Okay, so go ahead, read the problem just like yesterday. Once you solve it, just send me a message. Found out a little late on yesterday that you can't actually post a comment to these videos for privacy reasons since this is a kids channel. So go ahead and message me or email me the answer that you come up with. So good job to those of you who got that out yesterday. Good luck, and I will talk to you guys tomorrow.